Yeah.
Good morning.
Good morning.
Morning, Tatiana. Ah, okay, girls. Just give me a second. Um, hey, ladies. Before we start, does anybody have any questions? Any questions about what we have talked about in chapter 18, 19? Okay. So today we're going to start off with chapter number 20, which primarily is mean, yes, okay, going to, we can say, yes, okay, optimizing, yes, okay, Doppler images. Which means will be about, okay, yes, different system settings that we will be able to adjust to, yes, okay, get an ideal Doppler image. But as we go along, yes, okay, and talk about, yes, okay, different adjustments, we may also, yes, okay, see that, okay, yes, some of these adjustments may have, okay, yes, negative effects, or we can say, it's okay, adverse effects on our Doppler images. Okay, so that is pretty much okay what this chapter here is about. And now before we start, girls, please, okay, we can say it's okay mainly or it's okay, basic main knobs. Okay, on our keyboard or console, if that's what you want to call it. We can say that this one here is okay, that was the B mode. Okay. This one here was color flow. Then we can see it's okay, we have pulse wave Doppler. And the last but not the least is okay, we can see it's okay that was M mode. Okay. And we probably are probably not going to yes, okay, we're bringing in yes, okay, the M mode in today's discussion. But one thing that we know is that B mode mainly is okay, we can say it's okay, or the way by which we as okay control the brightness of your, because it's okay, regular gray imaging. Did that make sense? Right, okay. Where we said that, okay, yes, if you, for instance, yes, okay, turn this knob here clockwise, that was going to, yes, okay, increase the brightness. Which we mainly said also because, okay, we increase the amplification. Right? Whereas, okay, as if we turn it anti-clockwise, that was going to, yes, okay, decrease the brightness. Mainly because, okay, we reduce the amplification. Right? Okay. We also said that, okay, yes, if we increase the brightness of the image or increase the amplification, that will actually is okay, lead to is okay, reduction of noise. Right, okay. We also said that, okay, yes, adjusting your B mode, either increasing the brightness or the decreasing the brightness of what we call gain. To be more specific, we call that as, okay, receiver gain. Is that clear? So another way or another word for SOK amplification was receiver gain, where we could still say SOK, we could increase the receiver gain, as we talked about here. Or SOK, we could SOK decrease the receiver gain, which was like this. Clear? Okay. Is everybody clear about that? Is everybody clear about that? Yes, Marissa, you want to say something there? You want to say something there? Now, girls, we can do the same thing on your color Doppler. Okay, which we mainly is okay, we'll just call color Doppler gain. Where we actually is okay if we, for instance, okay, let's do it this way. Turn that clockwise, that is going to, okay, increase the color Doppler gain. Whereas, okay, yes, we can turn it anti-clockwise, which means it's okay, will decrease the color Doppler gain. Likewise, ladies, when we, for instance, okay, have, for instance, okay, the pulse wave Doppler on. Now, what we mean is, okay, we'll see in the case of the pulse wave Doppler is going to be, okay, the spectral Doppler. So again here, okay, we can increase spectral Doppler gain, or we can decrease the spectral Doppler gain. Okay, so this is something that, okay, yes, is going to be brought up, yes, okay, later in today's topic, but mainly because, okay, yesterday, before it's okay, closing the class, I told you ladies to read on receiver gain, or what we, okay, just called amplification. Okay, so what these knobs here mainly are, they are all, yes, okay, receiver functions. Okay, they are mainly all going to be, yes, okay, receiver functions. Okay, the B mode is going to, yes, okay, if you have, yes, okay, B mode on, that's the only mode that's going to be on pretty much, okay, as soon as you turn the system on. But yes, okay, if you, for instance, okay, want to, yes, okay, have record a color Doppler, you have to turn the color Doppler or color flow on. If you want to, yes, okay, record a pulse wave Doppler, you have to turn on the pulse wave Doppler function. Okay, clear? Any questions? Okay, ladies, now first of all is going to be, yes, okay, normal incidence. Okay, now we talked about that in chapter 6. We said that, okay, as the normal incidence. But here we says, okay, for B imaging, or okay, so okay, yeah, okay, we can say it's okay, B mode imaging is a 90-degree angle. Okay, where I say it's okay, our primary goal in B mode imaging mainly is okay, was to get an image. But when we came to Doppler, we said that any angle but 90 degree will be considered as okay, the normal incidence. Right, okay. Because what we mainly saw is okay in case of is okay Doppler that okay as a 90-degree angle was going to is okay give us a 0 Doppler shift. So that's why we mainly see as okay any other angle but 90 degree, which we go say as okay anything between 0 to let's say as okay 89 degrees, and okay as 91 degrees to 180 degrees. Will be as okay what we could call as okay the normal incidence angles for Dopplers. Did that make sense?
Yes.
Okay, thank you. Now let us just look. And let's say that, okay, yes, these here is okay are your, we can say, okay, your screens of your image. And for now, let's just say that, okay, as the blood vessel that we are scanning mainly as okay are running across your screen like this. Clear? Now, you may turn on, let's say, as okay, your color Doppler mode. Clear? Or we can say it's okay. This is what it mainly as okay will look like as okay if you have a regular as okay B mode on. Or once you turn on as okay your color flow, what you may see is that okay, yes, a box like this. Now usually as okay, normally as okay, this would be yellow colored. Right. But before yes, okay, you turn on yes, okay, your color flow. This was your blood vessel, and oh, now what you mainly will see is that okay, the blood flow is going to appear okay as a slight grayish, darkish gray color. That's how it's okay. A blood vessel will look like on a regular B mode image. Now you turn on your color flow, and you mainly as okay get this yellowish outline box here, which mainly as okay it will indicate as okay the direction in which your beam is being steered. Now in this instance here, as okay, you will actually see that although your color flow was turned on, but the blood vessel doesn't show any color in accordance to, let's say, it's okay, the color map. And why is that? Mainly because right here, what if you look at it, you can mainly see that, okay, yes, this is the angle. Or we can say, okay, this is how your beam is being steered. And you can see, yes, okay, they all just, okay, make 90-degree angles in relation to, yes, okay, we can say, it's okay, the direction of the blood flow. Now here is okay, the blood can be flowing in this direction, or it can be flowing in this direction. It is in both cases okay, making, you can say it's okay, yeah, 90-degree angle with the direction of the blood flow, because this is your beam, and this was okay, yes, the either this direction or that direction. It doesn't really matter. This is a we have a 90-degree angle. And what we know that, okay, as a 90-degree angle is going to give us is, okay, as a 0 Doppler shift. Okay. And that's what the system will be recording, but that's okay on your color map. Over the color that indicated as okay as 0 Doppler shift, it was still black. So it's still recording it by saying, well, okay, we are getting a 0 Doppler shift because of the 90-degree angle. Did that make sense? So what would be the right thing to do here? The right thing to do would be to steer the beam. Did that make sense?
Yeah.
Right. Okay. Now you may say, okay, how do we steer the beam? Now again, yes, okay, girls, if you remember those 5 knobs right next to, yes, okay, to your touch screen. It's most likely going to be this one here. That is going to, yes, okay, right next to it says, okay, angle, yes, okay, angle. Okay, angle. And when you turn it, now the beam may be steered like this. Or you may see that, okay, as the box may go like this. Did that make sense? Okay. Where you can maybe now say, yes, okay, now the angle is anything but 90 degrees. Let's just say, for instance, yes, okay, because it's the same, yes, okay, blood vessel, but when yes, okay, just steer the beam in a different angle. Clear? Let's just say that, okay, our blood flow was in this direction. Now let's just make that down here. So let's just say it's okay that the blood flow, yes, okay, was in this direction here. Did that make sense? Okay. So over here, this is going to be, yes, okay. Oh, that's it. This is going to be, yes, okay, the angle between the beam and the direction of the blood flow. Yeah, you can say it's okay, the same here. This is going to be, it's okay, the angle between the beam and the direction of the blood flow. But we may can say, it's okay, this one here could be, it's okay, 60-degree angle where we could say, it's okay, this one here would have been, okay, as a 120-degree angle, for instance. Yeah. And now a 60-degree angle. That falls as a positive Doppler shift. where, okay, it's 120-degree angle, it's okay, that's a negative Doppler shift. But what you mainly will see is, okay, mainly it's okay by steering the angle so that it is anything but a 90-degree angle. All of a sudden, yes, okay, that blood vessel, which was, okay, first, okay, represent or showed up, okay, as a 0 Doppler shift, now have a positive Doppler shift, or in this case, here, it's okay, a negative Doppler shift. Did you guys get that?
Yeah.
Okay. Okay. So there's mainly as okay going to be as okay of those 5 knobs, I think in most systems that's okay. It's going to be as okay. The second was from the left, I would say is okay angle steer. Clear? Okay. And for this one here, it doesn't really matter whether you turn it clockwise or anti-clockwise, because that's okay. It may go from like even if you keep on turning it in one direction, it may go, it's okay, this, then this, then this. Then when you turn it, it goes back to this and then back to this. Even if you keep on turning it in the same direction. So it's not going to be that, okay, only if I turn it clockwise is the angle going to be steered this way. And only if I turn it anti-clockwise, it is going to steer this way. You can keep on as okay as twisting it in the same direction, clockwise, it's just going to go from, let's say, this to this. And as you go down, it goes back like this. Okay. But the main thing was that, okay, as we didn't want to have a 90-degree angle between the beam and, yes, okay, the direction of the blood flow. Did that make any sense? So this is mainly, yes, okay, how we, yes, okay, steer the angle. Okay. So although, yes, okay, you turn on your color flow mode, okay, although, yes, okay, you turn it on, and you say, but why in the blue is it that I'm not seeing, yes, okay, color Doppler, as okay, you can say, okay, the blood vessel should give me as okay any of the colors that's okay on the color map. That's mainly because okay, you have because it's okay a bad angle between the direction in which the blood is flowing and okay, yes, the beam. What will be that bad angle? That will be as okay a 90-degree angle. Okay. Now goes, it's not always going to be that okay, yes, that you have okay as a blood vessel that you scan that's going to okay run straight across the screen like this. Where we in this case could say it's okay, this would be a bad angle, right? Okay. Because okay, you can have screens, or you can say it's okay, scannings. Okay, let's just erase. Where we can say that okay, yes, the blood vessel is okay, maybe we can say it's okay to run. It's okay across the screen like this. Okay. And okay, yes, we still, yes, okay, let's see, yes, okay, our color map. Let's select this one, okay. Now, in this instance, yes, okay, if your box, for instance, okay, was steered like this. Okay, we can still say that, okay, let's just assume that, okay, yes, the blood was, it's okay, flowing in this direction. So although, yes, okay, your angle was steered at a tyndall angle across your screen, but yes, okay, since the blood vessel also runs, yes, okay, at a tyndall angle across your screen and not straight as we had here. In this instance here, it's okay, what is it we still have is that, okay, yes, if we say that, okay, yes, sorry, that if this is okay, the direction in which the blood is flowing, and okay, yes, your beam is steered like this, this still makes us okay, 90-degree angle. And that's why, yes, okay, this is still going to, yes, okay, mean, yes, okay, show you as 0 Doppler shift. Did that make sense? Okay. Okay. So although, yes, okay, your beam was steered, okay, at a slanted angle across the screen, but because the blood vessel was running at a slanted angle across the screen as well, that's okay. It's all a matter of, okay, the direction between, yes, okay, the beam and the direction of the blood flow. If that makes a 90-degree angle, well, okay, yes, you will have a 0 Doppler shift. Whereas, okay, in accordance to, yes, okay, to the color map, yes, okay, 0 Doppler shift is black. That's when we can mainly say, yes, okay, we can steer the box like this. And goes, it is the same knob that we use, okay? But we can still say, okay, okay, as your color flow, yes, okay, that is on. But if you see this, you should be able to say, well, okay, well, that's because of, okay, as a 90-degree angle between the beam and the direction of the blood flow. Whereas you may say, well, okay, and we still say it's okay that the blood flows in the same direction, like this. So we can say, okay, it's this, but now, yes, okay, this is the direction of your beam. Yeah, okay, this becomes the angle. Okay. And that's going to, yes, okay, we can say it's okay. Let's just assume that this was 60 degrees. Here, that it is 60 degrees, so yes, okay. 60 degrees is a positive direction. Whereas, okay, on the other hand, yes, okay, we can also, yes, okay, steer the angle opposite to this one here. Okay. Okay, let me see. So we're going to go. Yeah, this is where I usually is okay. Let me just bring this bus vessel down a little bit. And we see, okay. Yep. Where it's again going to be, okay, the blood is the same blood vessel. Okay. Where, okay, yes. It says, okay, the blood was flowing in this direction. And now, yes, okay, this is going to be, yes, okay, we can see the angle of our beam. Okay. And this is just going to be, yes, okay. Another angle that we can say is okay, maybe 30 degrees, for instance. Which, okay, is still maybe positive. Did that make sense? Okay, but please keep in mind, guys, it's only going to be as okay inside the window, inside this yellow box here, in all instances. So even here is okay. This is going to be this, okay, like this. There you actually is okay. We'll see the color. Okay, okay. Now you mainly will say that okay, well, okay, that this is just okay what you're scanning. Let's say that okay, yes. Oh, let's do it this way. That's what it is. Because you say, well, okay, yes. Physically speaking, yes, okay, this is where my transducer is. Right, okay, okay. So you may not physically move the transducer, but what you actually is okay do when you say, well, okay, so right now it's okay. For instance, okay, at first, if your beam was steered like this, that when you says, okay, that the PCTs fire at pretty much, okay, as the same time, right? Right, girls?
Yeah.
Good. Where we can now say, now what is it that we do when we, for instance, okay, let's say it's okay, turn that knob that says, okay, angle steer. Okay. Let's say, okay, as we turn it one way, it's okay, the angle is going to, let's say it's okay, be steered in this direction. Okay, we mainly say that's mainly going to mean that, okay, this PCT will be the first one to fire. And this one here will be the last one to fire. So us turning this knob here actually means it's okay, sends a message to the electronics of the system, telling it, well, okay, yes, we need you to electronically, yes, okay, steer the beam here. And then yes, okay, now we can make that this will be first, and this one here will be the last to fire. And that's how, yes, okay, electronically speaking, now the beam is being steered in this direction. Okay, we can turn it one more tick. Okay, it may go back to this, but then yes, okay, we give it one more click. Let's see. Okay, and now all of a sudden, yes, okay, the beam may be steered in this direction here. Very mainly says, okay, now this will be the first PCT to fire, and this one here will be the last one to fire. Did that make sense? Okay. But that's okay. Why is it that we, for instance, okay, want to steer the angle? Mainly to make sure that, okay, yes, we don't have that 90-degree angle between, yes, okay, the beam and, yes, okay, I guess that's okay, the direction in which the blood is flowing. Okay, so that's okay. If it was flowing this way here, for instance, we can now say that, okay, yes, this here, that's just a lesser angle. Or we can say, okay, well, be something like, let's say 30 degrees, or 60 degrees, or 45 degrees, or whatsoever. Okay. Whereas, okay, yes, this one here would be a greater angle because that's okay, 120, 130, 140, whatsoever. Okay. Yeah, okay, yes. In this instance, yes, okay, this was going to be, yes, okay, a positive double shift. This one here, yes, okay, would be, yes, okay, a negative double shift. Where the vessel main, yes, okay, is going to be filled with the color accordingly, yes, okay, to your color map. Okay. But mainly, yes, okay, us twisting, yes, okay, this knob here, let's say it's okay, angle steer. Mainly, yes, okay, direct the angle or direct or change the angle in which the beam is going to be steered. So yes, okay, this means yes, okay, sends a message to the electronics or electrical source of your channel. Did that make any sense? Okay, so for us, it's just a slight twist in the kaleidoscope. And okay, as all of a sudden, yes, okay, the pattern, the colors change. Any questions? So just because you turn on your color mode, or we can say like a color mode, color Doppler, or color flow as, okay, as the system may label it as, doesn't necessarily mean that you automatically, as okay, will get a color flow. Because if your angle is not, let's say, it's okay, the right angle for a Doppler, which is then going to be, as okay, a non-right angle. Okay, anything is okay other than 90 degrees, you will not have a color Doppler shift. So your system will say, well, okay, well, you turn on the color Doppler, but right now it's okay, the blood is flowing at a 90-degree angle to my beams. So that's going to be as okay, a zero Doppler shift. Okay, so the first thing that, okay, is you most likely would like to correct should be your angle. Did I make myself clear on that one?
Yes.
Right, okay. And okay, as you tick, 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 start twisting, you may see that, okay, yes, the color appears. But if you keep on twisting, yes, okay, the angle is just going to keep on tick, 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 tick. That's okay. keep on, yes, okay, getting steered back to 0, and then, okay, yes, another angle. Now, does anybody have any questions?
No.
Anybody want to say anything? Okay. So yes, okay, on your is it written on your practical sheet? It should be. Just yeah, okay, on a color Doppler, and okay, yes, on a color Doppler, it says okay, box steering. That's all we'll be doing that, okay? Yeah. And okay, yes, on so spectral Doppler, it just says okay, angle steer. Clear? Okay. So we most likely, yes, okay, we'll look at that on yes, okay, on Tuesday, hopefully. Okay, girls. Now, next issue. Let us put it this way. Let us say let us say, okay, yes, just to make it simple. It's okay, this is our blood vessel. And so, and okay, let's say that, okay, yes, we have our, in all cases here, yes, okay, we have our box. Steered so that it doesn't make that we don't have it, okay, yeah, that it's not going to be as okay a 90-degree angle between us, okay, the direction of the blood flow and the pulse or beam. Okay. Because we come in, says, okay, this would have been a 90-degree angle. So you turn on your color Doppler, you steer the angle to, let's say, it's okay, a correct normal incidence. Anything but 90 degrees. But ladies, we can say it's okay, in accordance to your Doppler, color Doppler. That's okay. Your blood vessels still don't have any color filled in it. Clear? Okay. So we say it's okay, well, okay. And your color flow, that's okay, he's on. Your angle is steered in our correct direction, but you still don't have any color flow. Now, why is that? Now, this is mainly as okay, where we can say as okay that what I talked about in the beginning. This thing here is okay, comes into the picture. Did that make sense?
Yes.
Okay. Now, just like as I say, it's okay, just like your B mode. Right, okay. Okay. When that was on, if we turn clockwise, that was going to just okay, mainly make okay as the image become because it's okay more brighter, mainly because of an increase in the what we just okay just plainly call as okay receiver gain, transducer gain, power gain, energy gain, all that. Clear? But what was it that we did? We actually as okay increased the intensity of the signals that was reflected back. Clear? Okay. So in a B mode image, that's okay. We could have just okay something which was because that's okay. Whatever was too dark, we will make it brighter by increasing the receiver gain, right? Okay. So that's when it went from okay as from too dark to just okay, just correctly dark. Okay. Just the right brightness. Right, okay. But that's okay. On the other hand, we could also have that's okay an image that for instance okay was too bright. Now I know you may talk a lot and all that, but that's okay. If you say okay, only by that's okay adjusting your V mode knob, for instance. Well, okay, yes, you can reduce that. Okay. You can reduce the brightness. And that's cause an image that was too bright to just become right bright. That's okay. Uh, just bright to is okay to the what you can say is okay. What may is okay be more suitable for light. What we also knew was that okay, the image that for instance okay was too bright. There was going to be as okay a greater likelihood of noise because as we increase the brightness, which is mean it's okay going to be an increase of the signal. What this also did was that it equally as okay increased as okay the amount of noise. So ladies, right here is okay, although yes okay your color flow is on. We may even say yes okay here. We even yes okay steered the angle to a correct angle so that it was nothing or that it was not a 90-degree angle between yes okay the direction of the blood flow and or the direction in which the beam was being steered. But our blood vessel may still appear as okay as it has a zero Doppler shift. And that is mainly because we can say, okay, here's okay, our color Doppler gain, which mainly is okay, just took from okay as Similarly, okay, from your receiver gain, where okay, if the receiver gain mainly also is going to just okay control the brightness of your image. Was, for instance, okay, is too low. So even though blood is flowing in the blood vessel, even though it's okay, we have, we can say, okay, a non-90-degree angle between, yes, okay, the direction of the blood flow and the beam. But mainly because, okay, our color Doppler gain is too low. It will not display, yes, okay, this blood flow here and with color. So what we actually, yes, okay, can do is we can increase the color Doppler gain. How do we increase the color Doppler gain? Mainly, it's okay, just like as we did with our receiver gain or B mode, turning this knob here clockwise. And then what we will see then is that, okay, yes, now this blood vessel here will start having, oh, yes, okay, showing up a Doppler shift. Did that make sense? So ideally, we can say, okay, this one here is just right. Just as, okay, the right brightness. Okay, right Doppler gain. Okay, but what actually is okay, okay, what actually is okay may happen if we, for instance, okay, keep on increasing the color Doppler gain too high. What we actually is okay will see is that okay, we have our Doppler shift. But this image here is actually as okay now going to as okay, we can say it's okay get as okay actually producing as okay, or we may call as okay too much noise. And when okay, yes, when there's too much noise in the party, that's when the Paniara breaks. Or Paniara, that's what you call it. And okay, as what is it you get? Confetti. Or the main yes okay call this yes okay the confetti effect. Which was mainly we can say yes okay, good is good. Increasing the Doppler gain, yes okay, to make it yes okay. At least show some color is good. But then too much good becomes bad. Okay, where we may says okay here, this is mainly as okay where we increase the Doppler gain too much. Just give me a sec, please. Did you girls get that? So you can mainly see that okay, yes, if you see something like this, or if you see it's okay, what we call confetti effect, what would be the right thing to do? The right thing mainly would be to, yes, okay, do to, because that's okay, reduce your color Doppler gain. Okay? And that's going to, yes, okay, mean is okay. We can say get rid of the confetti effect, which means yes, okay, will just be, yes, okay, the noise of your color Doppler. So if you see something like this, you mean as okay, we'll turn your color flow anti-clockwise to bring it back to something like this, where you say, okay, well, okay, we just have, okay, yes. Like this. But if you keep on, let's say, as okay, further reducing your Doppler gain as okay, you may end up with something like this, which is, well, okay, too low of a color Doppler gain. Clear? Okay. So if you see no color Doppler gain, then okay, yes, you can, okay, yes, increase the color Doppler gain by turning the knob clockwise. It may bring you to this. Well, okay, this should probably, yes, okay, be the point where you should stop. But if you keep on, yes, okay, increasing your color Doppler gain, yes, okay, you may get this. But okay, this confetti effect here, I mean, is okay, is just going to be as okay, the similar as we can call as okay, the noise of your color Doppler. Did you ladies get that?
Yeah.
Okay. Um, okay, girls, could you just excuse me just for 2 minutes? I have a call of duty. Okay, girls, I'll be right back. Okay, girls. Um, so if you look on your yes, okay, sorry, practical sheet, what we just talked about is what they, yes, okay, call gain in color Doppler, and okay, yes, when it says spectral Doppler, it says Doppler gain. But they both are Doppler gains, okay? Okay. Uh, but we can say it's okay, this was, okay, this one, you can't see it. But this one means, okay, what we might see or may see in a color Doppler, where he says, okay, too much color become, yes, okay, like what we call the confetti effect. And that is when your neighbors calls the cops on you because the party gets too loud. Okay. But control wise, this is mainly as okay, how you may control it. A clockwise rotation on your color flow is going to just okay increase your color Doppler gain from 0 to okay, yes, whatever. But if you keep on increasing it, it may yes, okay, become too much color flow. That we call confetti effect. So if you see something like this, you'll probably just okay like to decrease it, decrease your color Doppler gain by turning this knob here counterclockwise. Okay, but hopefully it's okay. You should stop when you get to this point here, Because if you keep on decreasing the color Doppler gain, you may go from a color Doppler recording to just where it becomes 0. Okay, 0 in the sense that yes, the intensity of yes, the reflections produced by the flowing blood is going to not be amplified enough to show the color in accordance to the color map. Did you ladies get that?
Yes.
Okay. Now, ladies, on the other hand, the same can also be do as this is spectral Doppler. And we say that we can have a spectral Doppler gain. Okay. Now, ladies, please just assume. I'm sorry. That as whatever is white on the board here is black. And whatever is maybe shown with a color will be white. So we can say we have is a spectral Doppler. We have a spectral Doppler. Usually it's this will pop on when we turn on the knob that's called pulse wave. Okay. All you actually see is it says PW or PW or PW, sorry. Okay. So these are your spectrum. So that's there is our knob. And yes, we have turned it on. And what we have ensured is that yes, that in our B mode image, then we have yes. Now yes, the main thing here is that yes, you want the pulse, sorry, your sample gate window to be as perpendicular to the or longitudinal to the flow of the blood. Let's say as your blood flows like this, you want your sample window to be at this angle here. So we can say in this instance, yes, if the blood vessel, for instance, was running like this along in your image, you may like to steer it. So as your sample window is like this, but please, it should be inside the blood vessel. Because the blood may be running, let's say, in this direction here, or in this direction. Okay. No, that's not something that is mentioned in this book, but that's mean it's going to is be one of the major points. There you say, well, put the sample window within the blood vessel, but I still don't get a Doppler shift. That's because your angle is not correctly steered. Okay, but that's we can say is our pulse wave mode is on, and you have a spectral Doppler. Now, what you may see is that, okay, as your spectrum, okay, and that's why I say, okay, please consider that, okay, as all the white here is black. Because it's okay, black is white. Okay, and what I may as okay show with okay as any color that I do as a draw is going to be as okay. I guess that's okay. Any other color? Let's just say it's okay that we use red. Red is white readings. Okay. So right now, it's okay. All of your background here is. Let's just write it down. Black. Which mainly means that okay, yes, you are not recording any Doppler shift. Now you make sure that okay, your sample window or sample volume, as your book may also call it, is at a correct angle. Your angle is, yes, okay, also steered correctly. But you still don't have, yes, okay, Doppler shift recording on your, what you want to call it, on your spectral Doppler. And that's maybe, yes, okay, just because the same thing has happened as we had here. That we mainly can say, yes, okay, that your pulse wave Doppler or your spectral Doppler gain was too low. So even though, yes, okay, blood is flowing, the velocity of the blood is being, yes, okay, recorded at the window. But when those recording as okay comes back and should be as okay displayed on the graph, the graph is actually as okay not bright enough. You may see as okay some light dots, but you don't see as okay a good solid outline of the graph, which is mainly as okay because of a too low spectral Doppler gain. So practically, yes, okay, we can mainly, yes, okay, increase the spectral Doppler gain. And what that is going to do is that you can say, okay, you may actually, okay, start seeing is okay, your as okay, spectral Doppler. Did that make sense?
Can you repeat that for me?
When you increase your spectral Doppler gain, mainly as okay by turning as okay, your pulse wave Doppler knob clockwise. What will happen? That actually is okay. Practically what happens is that okay, as the recording of your Doppler shift, or we can say okay, the intensity of the signal of the reflectors, which was okay, as you were moving blood cells, the intensity of those signals are increased. And okay, it's actually going to appear more bright on your spectrum. Okay. Did that make sense? So that's
Yeah.
okay. Now, okay, yes, you can say, okay, a spectral Doppler recording, which actually is okay, is so weakly recorded because okay, your power or okay, your spectral Doppler gain was too low. Although yes, okay, you had done all the other things that okay as should have given you okay this reading here. Okay. But you may say, well, okay, why don't I see as okay a spectral recording? Although okay, I'm scanning the patient, I know that okay as my sample window is within the blood vessel. The sample window is also as okay at the correct angle and all that. You made sure that all those things were right, but you still didn't see as okay a spectral Doppler recording. Where you may as okay don't see your graph. But, okay, so that's when you can say okay, let me just increase on what we just okay call the spectral Doppler gain, which mainly means okay as the intensity of these reflections here is going to be increased, just as we had in receiver gain in B mode, just as we had in color Doppler gain in color flow. So we can mainly say, okay, out of this is, okay, this fellow here, or this one here, is ideal. You say, well, okay, yes, okay, I have my Doppler shift. That's all I needed. But for instance, okay, if you keep on, let's say it's okay, increasing on your Doppler gain, what you actually is okay may end up getting is, we can say, okay, that very yes, okay, same Doppler gain. But what is it that you will get as well? Is that all of it, all of your spectrum is going to be as okay, we can say it's okay, contaminated by as okay, small white dots. Yeah, this mainly mean that okay, yes, you increase the power of spectral Doppler gain too much. So what these here make as okay, there could be as okay, there will be as okay, the similar to as okay, the confetti of your spectra of your that we had in the color Doppler. Or we can mainly says, okay, what is it that it's going to be? They mainly as okay represents noise. Why? Because okay, you increase the receive spectral Doppler gain. You can say it's okay, too much gain. Too much gain leads to noise. Just like okay, yes, too much gain, yes, okay, leads to noise, which we called confetti. In B mode, too much gain leads to noise. Did that make sense, my dear?
Yeah.
Okay. Now, does anybody have any questions? So if you see this, the best thing to do would be to reduce your gain. So you get this. But if you keep on reducing your gain too much, then you may go from this to this. Okay. Or you may even go as okay, where you as okay, just have okay as an empty spectrum where there's no reading. Why? Because okay, your spectral Doppler gain was too low. Is that clear?
Yes.
Good. Okay, ladies. Now one thing, and that's most likely as okay where you may get food. And let me just say it's okay, you have two different spectral recordings. Let's say it's okay, this is one. Let's say it's okay, this is another one. Now in one case, we can say, okay, this is A. In the other case, right? And we can say B. Now, ladies, there are different things that they can ask you as okay in relation to A and B. They may ask you in A, okay, what is this called? So is there anybody who will be able to just, okay, tell me, yes, okay, what is it that you see here? You have different options. What do you think something like this here represents?
Noise.
No, not really, my dear. I would say this over here is okay, would be noise.
Is it spectral broadening in A?
Exactly, very good. Spectral broadening. Why? Because you mainly see as okay, it's only as okay the spectral windows that may be as okay contaminated by what we can mimic as okay refer to as noise. Did that make sense? So they may say, okay, we call it spectral broadening. They may also, they can also give you the same question and say, okay, it's okay, what does this represent? And then you can mean, okay, it will be as okay, a turbulent flow, right? Because when we have spectral broadening, that mean indicated as okay, that we had a turbulent flow on a spectral analysis, right? Or we can say, okay, fast Fourier transform. Whereas over here, yes, okay, we can say, yes, okay, what caused this one here? Or B? Too high spectral Doppler gain. Just what we did here. There you actually see that, okay, it's the whole, your entire, yes, okay, spectrum that is going to, yes, okay, B, because it's already contaminated by noise. Just as we had in confetti. Just as, okay, as if you increase your B mode or brightness too high, your image starts becoming as okay, you can say it's okay, too bright, but it's also going to be as okay, increasingly contaminated with noise. Did that make sense? Right, okay. That's why I asked you ladies to just read on the receiver gain. Clear? But again, ladies, that's okay. Likewise, you can be given, yes, okay. This image, and they may says, okay, what can you do? Scooby-Doo, what should you do to correct this image here? The correct thing to do is going to be as okay is to reduce your Doppler gain. Or you can say okay, your spectral Doppler gain. Whereas okay, if you see this image and they say Scooby-Doo, what can you do? Well, okay, yes, increase the Doppler gain because we want it to be something like this. So that we have okay as a recording of the spectral Doppler visible on the spectrum. Either. But don't get fooled by this versus this. Did that make sense? Because this is going to be as okay an example of this okay spectral Doppler. Oh, sorry, spectral broadening. Clear? Which indicates turbulent flow. Why I mean because okay, it was our spectral windows that we could say it's okay was as okay contaminated by noise. Whereas here, this was going to be as okay a generalized noise over the entire spectrum. Which means okay was because it's okay your spectral Doppler gain was too high, as we had here. So that's okay here. The solution is clear. That means it's okay, only one thing that can be done. What to do is reduce the spectral Doppler gain. Clear? What can be asked about here is okay, what can be done here? Well, okay, if it wasn't actually as okay, turbulent flow, there's not much you can do. Turbulent flow is there. It's there. Clear? But you stay as okay. You may be asked about as okay, this image here, which okay as looks like okay as what we call as okay turbulent flow, which is represented as okay a spectral broadening. But then think of those as okay for possible imposters that we talked about. The Doppler gain was too high. Well, okay, that's what it will look like this. Clear? Okay. But then we talked about yes, okay, the window, sample window be too big. Okay, yes. A poor angle. And okay, yes. That okay, yes, your sample window was too close to the vessel wall. So I gave you yes, okay, I gave you guys yes, okay, that list of those spectral broadening imposters for a reason. Did you girls get that? So you can say good is good, but then too much good is bad. Anybody want to say anything? Okay. So it's pretty much not new information. You may think it's new information. No, it's not. It's, if you look at it, yes, okay, it's just okay as your amplification repeated over again. But yes, okay, here you say color. Here you say, yes, okay, the bright signal that's going to be recorded as okay as a spectrograph. That's how you'll be able to just okay copy and paste. Okay, goals. Now just take okay as a should we say that you can take a short break, read through yes okay these couple of pages here, look at the pictures given in the book along with them. Okay. And before we continue, if you still have any doubts about yes, okay, your aliasing, you may ask now. If you still have any doubts about the charts of aliasing, you may ask now. And when I say the charge of aliasing, primarily, yes, okay, that increase in the scale fellow. Now your book says increase the scale. We said, okay, as we increase the PRF. Okay, girls. So I see you ladies at 11 o'clock. Okay. So please try to read through these pages here and okay, let's read on your aliasing. And we will continue them. Okay, girls. Welcome back. Any questions? Yes, girls. Nothing?
No.
Okay. aliasing. Now, what did we say the aliasing was? We can say it's okay, falsely positive, even if we had negative Doppler shift. Or likewise, falsely negative, even if we had positive Doppler shifts. But what is going to be is okay about is okay either the positive Doppler shift or the negative Doppler shift that we had was that these were greater than the Nyquist limit. Okay, now goes whenever we do Doppler, whether there was spectral Doppler or whether we say is okay color flow Doppler. When a color flow Doppler is okay, we had a color map. It's like this. And we can say for instance like this. Is that clear? Where in both instances, the Nyquist limit that we are going to have would be this would be our Nyquist limit. And or this would be our Nyquist limit. Barry says, okay, and all this was your baseline, which was your zero Doppler shift. You have your baseline here as well, which again is okay, would be your zero Doppler shift. Where we then could say that, okay, yes, these here would be as okay, your positive Doppler shifts. These would be as okay, your negative Doppler shifts. Now at this level here, it's okay, we may have a velocity written. You can say it's okay, for instance, 50 centimeters per second. And here is okay, we may also have another velocity written, which is okay, minus 50 centimeters per second. Which will be as okay, our positive Nyquist limit and negative Nyquist limit. Clear? Now on your color map, you will also have okay as a Nyquist limit mentioned, which we can say is okay. Let's just say it's okay, for instance, 40. So this will be as okay, plus 40. And this one here is okay, would be, this is okay, minus 40. Centimeters, meters, whatever, it doesn't matter. Did that make sense? Now, where we, for instance, said that, okay, yes, if we had a negative Doppler shift, if we had a negative Doppler shift. Okay, no, so we had a negative Doppler shift. Where we actually as okay also will see as okay a falsely positive Doppler shift. This fellow here was going to be as okay you were aliasing. Or likewise, if you had a positive Doppler shift, in which we as okay will see a falsely negative Doppler shift. This one here is okay will be the aliasing. Did that make sense?
Yes.
Good. Clear? So what is it we see that the aliasing is going to as okay or as okay is going to be located on the spectral Doppler? We had a positive, no, so we had a negative Doppler shift, where the positive Doppler shift, which was okay as the aliasing, was going to as okay be shown by the Nyquist limit on the positive side. Or likewise as okay, we had a positive Doppler shift with aliasing. That aliasing was going to be shown along the Nyquist limit line of your negative Doppler shift. I mean, as okay gives us an impression of as like we had a negative Doppler shift as well. Did you ladies get that? Now, if that was okay as the case in instance, that's okay that we had a blood vessel being scanned, that's okay using a color Doppler mode. Okay. Being scanned using a color Doppler mode. Now, what we mainly would see, and let's just say that, okay, as we had a negative Doppler shift. So you will mainly see as, okay, that something like this. So what does this color here represent? Okay, as a maximum negative Doppler shift. Because this color in this instance is going to mean is okay that it was able to record up to, let's say, is okay, what we had okay as our maximum is 40 centimeters per second of velocity. Where you within the same blood vessel might also is okay, let's say, see this color here. And this will be your aliasing. Which is that's okay as a color checking is okay from the extreme other side of your color map. Did that make sense? Okay, let's just say that each color here is okay represents okay as a scale of, let's say, as okay of velocities of 10 centimeters per second. So the max negative Doppler shift that we were able to record was 40 centimeters per second. That was just okay where our Nyquist limit was. But yes, okay, if the blood was flowing, let's say it's okay at 50 centimeters per second, that remaining 10 centimeters was going to just okay be represented by the red. Just like we can say, okay, this aliasing here is okay, will be shown up here. Or just like we can say, okay, this aliasing actually is okay, shows like here. Did that make sense? Okay. Now let us say that, okay, yes, had the velocity in this blood vessel here been more than 50. Let's say 55, or let's say even 60. Well, okay, the max per negative that we were able to record was 40 centimeters per second. Right? The 50, and the 50s is okay, that was going to be red. But the 60s, that's okay, you may have, okay, some orange as well. Did that make sense? Just like, okay, yes, you can say it's okay that you could have had, okay, as a velocity beyond the Nyquist limit, which was greater. Where you mean it says, okay, that this spike would have been created up here. Right, okay. Or likewise, this would have been, okay, yes, a greater velocity where this means, okay, would just have been, okay, yes, greater. Did that make sense? So what you may see in aliasing is that, okay, yes, the blood vessel is mean it's okay going to be filled by colors on, yes, okay, the extreme opposite poles of your color map. Just like on a spectral Doppler, that's okay, whatever your aliasing was, this is going to just okay be displayed at the opposite extreme pole of your positive part of the spectrum. This was actually just okay, was a positive Doppler shift, but beyond our Nyquist limit. Is going to just okay be displayed at the extreme negative pole. Did you ladies get that?
What does it say in the red?
Huh? Pardon me there?
What does it say in the red?
What was aliasing? What was aliasing, my dear? That we falsely have a positive Doppler shift, even though it's okay, the actual Doppler shift was negative, right?
Right, thank you.
And likewise opposite, that we have a falsely negative Doppler shift, although it's okay, even if we had an actually it's okay positive Doppler shift. Did that make sense?
Yes.
We had this positive and negative, false positive and false negative. Or we can say actually it's okay, this here, okay, was what we call aliasing. Did that make sense? Now you may say, yes, okay, Mike, how in the hell would I know that, okay, yes, I actually have, okay, yes, a negative Doppler shift is the actual one, and okay, it's the positive Doppler shifts that are okay as the aliasing, and not vice versa. Because some of you may say, well, okay, it could have been as okay that actually had okay as a positive Doppler shift was the actual one, and the blue one. Why is that not the aliasing in this case here? Is there anybody who can tell me why it's a negative Doppler shift and the red is aliasing? And not vice versa.
Because there is no black line in between them, so it's
No. Right now, that's flow reversal. You haven't got to that yet.
Can you please repeat the question?
My question is, how can I with surety say that in this blood vessel here, it's okay, my reading is a negative Doppler shift where the red and okay, as you went on, it was okay, increased orange was your aliasing, and not vice versa.
You said how to make sure if the orange is
And I'd be
aliasing.
so sure. That this picture here is okay, is a negative Doppler shift.
You just look on the color map. It says the blue is
Okay,
negative.
yeah. But what do I have? I have both positive and negative, right?
Yeah, it's overlapping.
Well, it's only one that can be true, right?
Yeah.
Mm.
So when you look at the map, you actually look which way it's going. And you see which one is.
My dear, where do you have a maximum speed? Where in the blood vessel do you have a maximum speed?
In the center. So aliasing occurs in the center.
No. This here is your aliasing, the reddish. Okay, that's fine. That's probably beyond your scope right now. Okay. But that's mainly as okay, going to be as okay, your aliasing. Now, my dear. Now, primarily as okay, how do we correct aliasing. Or we can say, okay, get rid of aliasing. Now, one of the main things that we talk about was, okay, as we increased what we call the PRF. Clear? In the previous chapter, that means, okay, well, okay, it says, okay, increasing the scale. Did that make sense? But what we actually meant, or what we actually as okay said by okay as increasing in the PRF was mainly as okay, or as I remember that what was going to happen is that okay as that there will be an increase in the Nyquist limit. So girls, if we for instance yes okay say yes okay this here is okay was our spectral Doppler, right? Okay. There is okay. We said okay as we had for instance okay 50 50. What was going to happen yes okay when we for instance yes okay increase the Nyquist limit. Or actually, that's okay. Increase the PRF. It was going to just okay increase the scale. So first, let's say it's okay. If we, for instance, okay, have had a positive Doppler shift. At this part here, actually, it's okay was missing because it was beyond the scale of our spectrum. It will show up as aliasing. Clear? Okay. Now we can maybe say, okay, that our scale here was, let's say, okay, just 10, 20, 30, 40, and 50. And likewise here, 10, 20, 30, 40, and 50. Now, when we increase the scale, that's okay. The size of the spectrum remains the same. But you may see that, okay, yes, because, okay, this was 0. But let's say it goes from, it's okay, counting by tens to, let's say, it's okay, 20s, for instance. So it goes 20, 40, 50, 60. And let's just say, okay, as our spectrum, yes, okay, it now ends at 80. And so here, 80. Let's just say that, okay, so our velocity in this case is, okay, the total was 60 centimeters per second. This graph is now going to just, okay, be within the spectrum. Or limits of our spectrum. As a matter of fact, let's go to the limit of 60. We can say, it's okay, we can further, that's okay, increase. And okay, yes. It may go like let's say it's okay to a max of 100. Where, okay, that's what will happen is the graph just becomes smaller. Now, what makes it smaller is mainly because the more we increase the scale, it becomes less sensitive to low velocities. Because now on our scale here, it's okay, 60 is going to be, it's okay, somewhere. Let's see, it's okay at this level here. Did that make sense? So likewise, girls, if we said, okay, yes, that we have a color map, then we can just say, okay, let's just say that, okay, these here are our positive color Doppler shift colors. And then we just go on the negative side. Okay. Now, let's say that, okay, here, our maximum positive was 40, for instance. And okay, says, okay, our maximum negative Doppler shift that we could record was minus 40. Clear? So whatever number you see here and here as a main, that's okay, that's going to be, that's okay, your Nyquist limit on your map. Okay, we may say that, okay, as we have a blood vessel in which, okay, let's say it's okay, a maximum positive Doppler shift is being recorded. And we can say this will become your aliasing. Now we may just, okay, just do the same. It's okay, we can say it's okay. But when we have our color mode on, we just, okay, may increase the scale. As far as, okay, as the composition of the color map is concerned, well, okay, it remains the same. It's going to be as, okay, the same colors. Pretty much, okay, as in the same sequence. But what you may see is that, okay, yes, this may, yes, okay, let's say it's okay, it increases to 60 and minus 60. And what you may see is that, okay, as now your aliasing is gone. And the whole vessel is going to just, okay, be filled out with red color. Because now red means or represents between 50 to 60 Doppler shift. Yeah, okay, we could say it's okay, the Doppler shift was plus or positive 50 centimeters per square or per second. Did that make sense?
I have a quick question.
Yeah,
So increasing the PRF is going to increase the color scale, like the color map?
no. Why would it increase the color map? The color map remains the same.
I mean, like the numbers, the
Exactly.
neg was like, yes, that's what I meant. I didn't
Because
mean like the colors, I meant the
exactly.
neg was.
Okay, so this just become, yes, okay, you can say it's okay, your new Nyquist limits. Just as you had here, is okay, you increase your Nyquist limit, it became from 50 to, you can say 80, right? Okay, we increase it even further, it became from, okay, 80 to, that's okay, 100. So the same is going to happen here. The more we keep on increasing the Nyquist limit, yes, okay, the values may, yes, okay, become 100. Because that's okay, 120. Did that make sense?
Yes,
Right, okay. Now what's going to happen, for instance, because we say that's okay, our velocity was 60 here. We increase the scale to, let's say it's okay, 200. Okay. Mainly because that's okay. That's okay. It's going to just okay be 50, 100, 150, and then 200. That's 60 centimeters graph. Because I mean is okay, the velocity that we had is going to be as okay a physically smaller graph. Right? Clear? Did that make sense? Did that make sense?
can you explain it a little bit more?
What do you mean? You increase the scale. What's going to happen? What happens when you increase the scale? First it was 50 was the maximum. Let me change it to another slide. 50-50. You turn your PRF, it goes 100. The graph is first was 50. That says, okay, what's going to be this? Now on your scale here, it's okay, 50 will be somewhere here. So that velocity, which was 50 centimeters, is going to just, okay, just produce a graph like this, right?
Okay, yes, I understand now.
Did that make sense?
Yes,
Good. So my dear, this very same thing here is okay, is going to just okay happen on your color map. Because okay, here we said okay, we had aliasing. This was a blood vessel with aliasing, right? We increased the scale, well, okay, we got rid of the aliasing. Yeah. You may increase it even further and say, okay, we increase it to twice what it was as okay as here. Where you can mean it says okay, now red on the positive side and okay as this sickening green on the negative side represents velocities of 120 and 120. we can say it's okay, orange on the positive side. Okay, we can say, okay, from 100 to 120. So this orange on the positive side, and okay, there's dark green here on the negative side, meaning it's okay, we represent velocities between, it's okay, 80 to 100. Then we go and say pink. And okay, it's light green. And then okay, yes, this pale purple. And yellow, and okay, yes, like this. Now, what was our velocity? It was 60. Now, in that very same blood vessel, yes, okay. 60 was before, yes, okay, red. Now 60 maybe, yes, okay. Let's say it's okay, and have these two colors here. So, and we had a positive Doppler shift. So let's just say it's okay, that okay, 60 is okay, it's purple. Or this pink. Did that make sense? Because this speed here is okay, this color here, that's what actually is okay, now represents 60 as we increase the map. Oh, sorry, not increase the map, sorry. Increase the scale on our color. Just like it's okay, this switch was 50 in the beginning. As is okay, like this. When we increase the map to yes, okay, 200, 50 is going to be yes, okay, somewhere down here, right? Did that make sense?
Yeah.
Right? Did you guys get that?
Yeah.
Okay. Now, if we keep on, if we, for instance, okay, keep on increasing our scale, okay, okay, yes, 50 was okay, yes, just barely as okay enough. But if yes, okay, increase the scale, that's okay, even beyond 300, let's say it's okay, we take it to 500. Okay, sorry. It's okay, this was our spectrum. And okay, as we said, okay, as Nyquist limit was 50. That just says, okay, not really releasing, we can say, okay, okay, that just touches, okay, at the 50. Now, when friends, yes, okay, let's say, okay, as we increase the scale here to 5 times. Let's say, okay, 10 times. This becomes 500. Here you can say, okay, this line here will be 10, 20, 30, 40. Now here's okay, each line will be 100. So where do you have your 150 now? Something like this. Right, okay, because it's okay by increasing PRF. Which is okay means is okay increasing the scale. We mean is that okay, so it becomes less sensitive to low velocities. Which okay, as we started off with a relatively as okay low velocity. Not to talk, okay, had this been, yes, okay, has this been 70? Or had our, yes, okay, Doppler shift been, let's say 70? Or, okay, yes, 20 of that were being shown down here. But even, yes, okay, here, you increase, yes, okay, the scale from, yes, okay, 50 to 500. Well, okay, at that 70 will still be like this. Slightly greater than 50, right? Did that make sense? Did that make sense?
Yeah.
Good. Because, and that's what is going to be asked, girls. In all sorts of crazy ways. But usually it's okay if you have a let's say it's okay color Doppler image. No, it's going to be too big, sorry. Okay, that's because we can say it's okay, we have an image here. And okay, now this is non-mirror imaging, okay, girls? This is non-mirror imaging. Or we have an image which is okay with two blood vessels. We can just label the blood vessels as A and B. Is that clear? Clear? And just so we know, yes, okay, what to compare it with. Okay, is going to be, yes, okay, the second copy of our image. And this is still going to be, yes, okay, blood vessel A, and this is still, yes, okay, our blood vessel B. Yeah. Now, here is our color map. We can say that, okay, these were our positive Doppler shifts. And these here. That's it. And okay, that's that blue. But all negative Doppler shifts. Did that make sense? Now, girls, what we mainly can say is that's okay in vessel A. Here. We have aliasing. So it's okay in vessel A. It's okay, A stands for aliasing. Okay. Whereas in vessel B, what you may see is, okay, yes, in this instance, is okay, here are very low negative Doppler shift. Here, whereas, okay, in A, what did we had? Yes, okay, we know we had aliasing in SLA because it's just, okay, colors from, yes, okay, the two extreme poles of our color map that are seen in the vessel. Whereas in vessel B is, okay, what we actually have is, well, okay, it's a negative Doppler shift. Not just a negative Doppler shift, is okay, it is a low negative Doppler shift. Did you ladies get that? Did you ladies get that?
I didn't.
Yes.
Huh?
I didn't. So the negative with the arrow pointing down.
Yeah.
For B, what do that represent again?
This is a negative Doppler shift, right?
Yes.
Why is it a negative Doppler shift? Because this color here is on the negative side of your color map, right?
Yes.
Right. All
That's it?
these, my dear, are negative Doppler shift, right?
Yes.
And we can say, so, okay, all these here are positive Doppler shifts, right?
Yes.
Good. Now, what is it that we see? How do we know that A has aliasing? Mainly because, okay, it has colors from both the extreme opposite poles of the blood vessel, of the color map, sorry, inside the blood vessel. So this is actually, okay, the muscle here that, okay, shows aliasing. Very convenient says, okay, that, okay, the velocity in this blood vessel here most likely is going to, yes, okay, be greater than the Nyquist limits. Right?
Right.
Good. Now our thing is we want to get rid of aliasing. Right. Okay. And the way that we made this, okay, will say is, okay, is by as, okay, increasing the PRF. Did that make sense? So, and we as, okay, increase the PRF. Well, okay, the configuration of your color map doesn't change. It still remains the same. Is that clear? So as far as, okay, as the colors that you have in your color map does not change as you increase the PRF. The only thing that will change is that, okay, yes, sorry. These numbers here may increase. So what mainly, yes, okay, may happen is, well, okay, yes, that aliasing color here is going to disappear because, yes, okay, right, okay, so now you don't have aliasing anymore. Did that make sense? Did that make sense?
Yes.
Baker says, okay, why did we have aliasing? Mainly because, yes, okay, the speed at which the blood was flowing was greater than 60. That's why, yes, okay, we got some of the blue color, which was the opposite end of your color map here. It disappeared. Now, what may happen in the first place, yes, okay, that, okay, yes. Okay, sorry. This blood vessel here is okay, maybe, yes, okay, less filled out. Now, what may happen is, okay, we can, yes, okay, if we keep on, let's say, yes, okay, if we still, yes, okay, increase our Nyquist limit. Now, I'm not going to be sitting here, yes, okay, and drawing, yes, okay, a new color map, but okay, yes, we can say, yes, okay, that it goes to, let's, okay, 100 and 100. What actually is okay may happen in that instance is that, okay, yes, that vessel A, which, okay, up here was, okay, as well filled out. Okay. And okay, yes, vessel B, which okay, yes, when we had increased, yes, okay, from first stage to second, yes, okay, was less filled. That okay, your red vessel, it's okay, vessel A becomes less filled. Or we can say it's okay, even it's okay, let's say it's okay, maybe it's okay, change the color. But where you actually will see that okay, vessel B now loses its Doppler shift. Now, why is that? Mainly because, as we said, Doppler is okay, B head was a, but okay, first of all, it was negative, contra to yes, okay, or vessel A, which was positive Doppler shift. But the main thing was that okay, as we said, okay, as this blood vessel here had a low Doppler shift. That was why it's okay, it was represented by as okay, a low velocity color on the color map. Right? A low velocity. And what happens as we keep on increasing the scale is going to yes, okay, become less and less sensitive to yes, okay, the low velocity in the vessel B. And okay, yes, it may become so less sensitive to yes, okay, that low velocity that it actually is okay, records as okay as a zero Doppler shift. If that makes sense.
Yes.
Here. You can say as okay, half a pound of sugar, or let's say it's okay, 1/10 of a pound of sugar is going to just okay be measurable on your kitchen scale. You take that on your bedroom scale, which is going to just okay be a greater scale, because it's going to just okay measure or it's okay way greater weights. It's going to be less sensitive to that. Not to talk about it's okay if you take that okay as half pound of sugar and want to weigh it on okay as on a scale that they use in airports or seaports and things like that, where they measure things or weigh things in tons, or hundreds and thousands of pounds, right? Did that make sense? So when we say that, okay, yes, increasing the PRF, well, okay, it increases the scale, but what was okay as an adverse effect of increasing the scale is that, okay, it becomes or it makes it less sensitive to low velocities. So yes, okay, if you have a vessel in which you see aliasing, well, okay, you may get rid of that aliasing in that specific blood vessel. But what may happen to yes, okay, to the recorded velocity in a neighboring blood vessel where, okay, the velocity is going to be relatively low. Forget about showing aliasing. That may be too low for the increased scale to be recorded. And you may actually end up seeing as, okay, a negative, oh, sorry, a zero Doppler shift in that vessel. Is that clear? Now, practically speaking, girls, because some of you will still, yes, okay, although, so that would mean is okay by increasing the PRF. And I already, yes, okay, told you girls, but that's fine. I don't mind repeat. And asking if you have a question is not going to work either. This knob here, it doesn't really matter which Doppler mode you turn on, whether you turn on the color flow and whether you turn on, that's okay, your pulse wave Doppler. The functions of this first key, which in B mode was focus position or focus number, which for me is okay, the number of focal points and okay, the position of the focal points could be adjusted. In color Doppler, okay, in Doppler modes, this knob's function here is going to just okay change to two things. One will be yes, okay, your PRF. And another function is going to be yes, okay, your wall filter. So when we say that okay, yes, PRF was the function that was outside the bracket. Okay, that may now mean that okay, yes, is the PRF that is active. And yes, okay, by us increasing that is going to just okay increase the PRF, which mainly will be yes, okay, the way that we increase the scale. And what you actually will see is that, okay, as on your spectrum, this part is, okay, max positive number, or max negative drop is okay number will increase. Likewise, okay, on your color map, the max positive velocity and or the max negative velocity, they will increase. And that's how it's okay, you increase the scale. Did that make sense?
Yeah.
Good. So a lot of this was not new. Okay. So you say, okay, increasing the scale is okay, get rid of that releasing. But actually what may happen is that you actually is okay, get rid of low velocities. And or, my dear, okay, by increasing the velocity, yes, okay, what's going to happen is that it's going to, yes, okay, become less and less sensitive to lower velocities. Where, okay, we says, okay, here we had aliasing mainly because, okay, the speed limit was exceeded. We increased the scale. Well, okay, as the blood vessel is now filled out. We increase it further. That blood vessel, which first had aliasing, then became as okay filled out as we, let's say, as okay keep on increasing the PRF. Actually, as okay may become less and less filled out. And what you mainly will see is okay, it is going to be as okay the blood flow right next to the vessel walls that will disappear. And why is that? Mainly because okay, it is by the vessel walls that okay, as the blood has the low velocity. So within this blood vessel, yes, okay, this is okay by the vessel wall. That's where you have the low velocities. So it's okay, you may see that okay, the blood vessel may become more and more and more emptied out. Appear as less blood is flowing through it. Mainly because it becomes less sensitive to, yes, okay, to those lower velocities in the blood vessel, which was okay as by your vessel wall, mainly because, as I said, the blood flow within blood vessels is parabolic. Where we had low velocities by the vessel wall, and okay, as the velocities increased as we went from the walls towards, as okay, the center of the blood vessel. Did I make myself clear?
Yeah.
Anybody has any doubts?
No.
Okay, girls. Any comments? Okay, girls. Now take your lunch break. Okay. And if you still are confused about your wall filter or ghosting versus, yes, okay, what the cluttering, please read on those. Okay. So I see you ladies back at 1 o'clock. Ladies, and welcome back. Okay. Any questions? So, okay. Just make this as an add-on node, okay? Then we can see requires okay, increasing the scale or increasing the PRF, which mainly means that okay, it's increasing the Nyquist limit. What would that lead to? Two things. First and foremost, that we get rid of aliasing. Right? The second is that we can say it's okay, that we also is okay. Okay, yes. May let's say it's okay, eliminate low velocities from being recorded. Why? Mainly it's okay due to decreased sensitivity. Did you ladies get that? Did you ladies get that?
Yeah.
Good. Okay, girls. Now let's just look at, okay, it's what we call, oopsie wall filter. Now primarily as okay, what was it a wall filter did? Because it's okay, let's put it okay, it only eliminated low velocities. Right. Okay. Or primarily, you could say it's okay. Cluttering in spectral Doppler, or what we as okay called ghosting in color Doppler. Did that make sense? Because both of these here, whether it was clustering or ghosting, mainly is okay, where is okay recording of low velocities. Did that make sense? Where okay, what the valve, and that's why we as okay said only eliminate the low velocities, because power is still going to be left behind, even though as okay we as okay applied our valve filters that okay as our high velocities in the blood vessels will still be recorded. Did you guys get that?
Yeah.
Good. So let us just say yes, okay. Again, yes, okay, we have two blood vessels. On a scan, we have A and B. Clear? Now let's just okay, yes, put okay, let's say it's okay that we have a color map. And then we just go with the blues. Now let us just say that, okay, yes, in one blood vessel. This way. Right, okay. We had a positive Doppler shift where that was going to be ghosting. And okay, yes, in a neighboring blood vessel. We have okay, yes, a low negative Doppler shift. Now, ladies, when we yes, okay, now apply the wall filter. Okay. Now, what you practically yes, okay, will see yes, okay, right next to your zero Doppler shift marker is going to be as okay a little marker or as okay bracket. That is okay, mean is okay may keep on expanding as you for instance okay increase our wall filter. And what would that mean? Or what is the guy going to indicate that okay we can say it's okay on our color Doppler, whatever color is okay is within the limits of the bracket actually is going to be eliminated. So what we actually as okay may get okay as a result of our wall filter here is that okay yes. Well, okay, yes, the ghosting is eliminated. But please keep in mind, ladies, that okay, as the wall filter is going to just okay expand on both sides of your color mat, both on the positive and on the negative side. So what it may do, only because in this case, yes, okay, in this blood vessel, yes, okay, we had a very low Doppler shift. All this, okay, just on the negative side. It will filter that out or eliminate it. So yes, okay, this blood vessel here is okay, maybe come. It's okay, you have a 0 Doppler shift. Clear? But, let's just say, had this blood vessel here have had a, let's say it's okay, a high. Okay, great. Okay, it's negative Doppler shift. Well, okay, yes, that will not have been eliminated. But by the wall filter, yes, okay, we then just got rid of the ghosting because only as okay took care of the wall filter means okay only took care of the very low velocities. Did that make sense? Did that make sense?
Yes.
Right, okay. Or pretty much okay, as if you go back and okay, yes, read on okay, yes, your wall filter. What I mainly said was, well, okay, yes, it only we can say okay, it removes very low Doppler shift frequencies. Okay. And we can say okay, let the high Doppler shift frequencies remain. So one example of okay as low Doppler shift frequencies would be as okay either ghosting. If we say yes, okay, a color Doppler, or cluttering if we said spectral Doppler. Clear? Okay, so on your spectral Doppler, for instance, yes, okay. Okay, we say yes, okay, we have a spectrum with let's see, yes, okay, cluttering. This was your 0 Doppler shift. And what's going to happen as we find this okay, we can say okay, activate or it's okay, increase on the wall filter. What you actually will see here is that okay, yes, a little bracket will appear. And what will it do? Very much okay, yes, eliminate all these frequencies here. So you can say it's okay, after as okay, introducing a wall filter, this very same as okay, spectral Doppler here, mainly as okay, with just and we can say okay, that is only going to be as okay, the great Doppler shifts. That would be mainly because what it was doing was very much okay as filtering out the frequencies in this area here. But it's going to just okay be equally on the negative Doppler shift as well. Is that clear? Is that clear? Now, what we also said that, okay, as your wall filter could do or eliminate was something like, okay, as what we call as, okay, the end diastolic speeds. Because we say as, okay, end diastolic speeds or velocities are also low when we measure it in the heart. No, sorry, in the blood vessel, sorry. Did that make sense? Did that make sense?
Kinda.
What do you mean kind of idea?
I'm like a little bit confused.
Why? I already the other day says, okay, if this was your spectrum. We said this here could be as, okay, your end diastolic speed or velocity. The speed of blood in the blood vessel at the end of diastole. And what was diastole? That was being is, okay, we can say it's okay when the heart expanded. However, it expand means it's okay to fill up with blood, right? So during your cardiac cycle, that was going to be as, okay, the phase at which is, okay, you had a slower blood flow in the blood vessel. Did that make sense?
Yeah.
Good. Whereas, okay, yes, what did we call this fellow here? We call that one, okay, as the end systolic velocity or speed, which was going to be as, okay, you can see as, okay, on the spectrum, it will be high, right? So although not written in your book, but okay, yes, please keep in mind that, okay, as the wall filter may be able to, yes, okay, also as, okay, filter or as, okay, your end systolic, end diastolic velocities. If the end diastolic velocity is low enough to, yes, okay, fall within the, you can say, it's okay, limits of your wall filter. Did that make sense?
Yeah.
Good. But what the wall filter won't be able to do it can't get rid of aliasing. Because, okay, what was it that aliasing was? Not only was, okay, aliasing okay, due to its, okay, high Doppler shift frequency, but actually it's, okay, very high Doppler shift frequencies. Okay, Doppler shift frequencies which were so high that, okay, yes, they didn't come in within the normal limits of the spectrum. Okay, because up here at some point is, okay, we had a speed which was greater than, okay, as our Nyquist limit. That will become aliasing, right? Or that is going to be as, okay, aliase mainly as, okay, in the form of like this. So your wall filter is not able to just, okay, filter out high Doppler shift frequencies, mainly because it only filters out low Doppler shift frequencies. Where do you find low Doppler shift frequencies? Well, ladies, on a color map, right next to your baseline. On a spectrum, well, okay, yes, low Doppler shifts. Are going to be as okay close to your baseline. Where, okay, yes, other graphs at least, okay, right? So small graphs, which are as okay right next to as okay or adjacent to the baseline, is mainly as okay due to low Doppler shifts. Clear? Whether they were positive, or we can say, okay, whether they were negative. So that's mainly as okay what the wall filter may be able to filter out. Where, okay, as your graded velocities, positive Doppler shifts, and or for that case, that's okay, negative Doppler shifts are not going to be filtered out by the wall filter. Did that make sense?
Yeah.
Yeah.
Good. So, ladies, you may come across, okay, as a phenomena, as many as okay mentioned in the book here, and that's what you call flow reversal. Now, if you just look at the word flow, what did that mean? Because it's okay, motion of, in this case, is okay, of a liquid. And we may say it's okay, reversal. Mainly it's okay, just like you put your car in reverse. What are you doing? You're driving in the opposite direction. Okay. But we mainly as okay, we'll have to just okay, differentiate this from aliasing. Now, girls, just look at it in this way. When your heart pumps, what does it do? Send out the blood, right? Because it's okay, at that point, it's okay, it is flowing at a, it's okay, great speed. Is that clear? Now, what happens after a systole or a contraction of the heart? The heart goes into diastole or relaxes. And this is a normal phenomenon because mainly as okay, we can say as okay as a reduced pressure gradient within the blood vessel. The blood that moves forward may move slightly backward. Did that make sense? So that's slightly as okay, you can say it's okay, backward flow. Welcome back of the blood in the blood vessel, which mainly happens just okay during diastole. It's for your FHUS flow reversal. Okay, so in both instances, whether it was flow reversal or whether it is aliasing, what we mainly as okay see within a well blood vessel flow reversal. What is it that we see in flow reversal? That there is both positive and negative Doppler shifts in a single blood vessel. That's what we also saw in the aliasing, right? Both positive and negative Doppler shifts within a single blood vessel. Okay. Did that make sense?
Yeah.
Good. So how would we know whether we see as okay, whether the blood vessel that we see shows what we call flow reversal or aliasing? Now, if for instance, okay, take our color map. And just says, okay, make it clear, it's okay, we can make it a color map with multiple colors. And then we can go and say, okay, this, and then we just go this. Now, in a blood vessel, if we, for instance, okay, had aliasing, let's just say that, okay, as we had a positive Doppler shift. Clear, where the speed of the blood and a positive Doppler shift was more than our Nyquist limit, we would have aliasing, which we like this. Where you mainly as okay, we'll see as okay, what is that we see in this blood vessel? We see as okay, colors from two extreme poles within that blood vessel. Did that make sense? So this one mainly means that okay, this vessel here is okay, displays what you call aliasing. Here on our spectral Doppler, we can mainly say as okay, now just to clarify as okay, this was our Doppler shift. That we crossed as okay. And okay, yes. This would be really easy. Did that make sense? Did that make sense?
Yeah.
Yes.
Okay, ladies. Now just look. What would it look like if we okay had a blood vessel? Well, okay, yes, no aliasing, mainly because first of all, that's okay, the velocities which the blood was flowing at, because as okay, was it within the limits of the Nyquist limits that we had set. But let's just say that okay, as we had a positive Doppler shift. And okay, we can say a positive Doppler shift. Okay, we may have okay, yes, let's say this color here. What's this? We may even as okay in this have okay as this color. Oh, sorry, let's just put it. All right, let's go to more accurate that way. That was, I guess, a little bit too much. And too much is bad. And we can say this color here. And what we then will see is zero Doppler shift, right? And then all of a sudden, right next to that, negative colors. Let's just say, okay, just this. Right, okay. So it practically says, okay, what we mainly as okay had in our blood vessel here is okay, was still yes, okay, a positive Doppler shift. Which means yes, okay, just went to yes, okay, a lesser positive. Then it became yes, okay, zero. And then it went on to yes, okay, a low negative. So you see here that okay, yes, the flow is okay, the colors actually is okay, go from positive like this, which is your flow reversal. Okay. Had it been, let's say it's okay, a negative Doppler shift, well, okay, it would just have been the opposite. Because it's okay, we start with blue, go yellow, then black, then okay, it's this purple color. Which means, okay, you practically had okay as a negative Doppler shift, or where the flow reversal was going to as okay, be positive. Mainly because the blood goes like this, slightly back, like this. So this is systole, diastole, systole, diastole, systole, diastole. Did that make sense?
Yeah.
Good. Now you may then say, well, okay, how is flow reversal going to just okay look on a spectrum? Let's just say, ladies, well, okay, as we had a positive Doppler shift. Okay, as we had here. We first says, okay, had a. Okay, now we want to just okay, be a little bit creative. This was all low positive Doppler shift. So, okay, we can say, okay, this will be, okay, the great positive Doppler shift. Okay. Okay. Then back to zero. And then this here. This would have been yes, okay, your flow reversal. That makes sense? Did that make sense, ladies?
Yes.
Good. So, what you're increasing of the scale also is okay, can get rid of is flow reversal. So can your wall filter also yes, okay, get rid of flow reversal. Because, sorry. Because what was it that your flow reversal was? Oops. Just okay as a low velocity flow of the blood in the opposite direction. Now you can say, as okay, what if you had a negative Doppler shift? Okay, you can say, as okay, you could have had okay as a negative Doppler shift. Okay, so you may just go and say, okay, like this. There you could say, okay, yes, then we had okay as a flow reversal, which means it's okay, just have been okay, like this. Is that clear? Okay. But what you mean is, okay, we'll see on a spectrum is that, okay, as your flow reversal is always going to follow the systole. At first you have a systole, and then you have flow reversal. First you have a systole, then you have a flow reversal. Did that make sense? But generally speaking, my idea is, okay, your flow reversals are just going to be a slight flow of blood in the opposite direction, but at a low velocity. You girls get that. So if you look at your flow reversal, that's okay. It's mean it's okay going to be colors not from the extremes of your color map, but it's okay just around your zero Doppler shift.
What does it say in the black?
Black flow
Yeah.
reversal is always going to just okay follow the systole. You see, this is how your graph goes as you record. So this is first, followed by this. Or you can just look at it in this way. Heart contracts, right? Blood flows. After a contraction, what happens? Heart relax, flow reversal. Did that make sense?
Yeah.
Good. Any questions? So wall filter, ladies, does not get rid of aliasing. Okay. It's only going to be as okay, not only, like you say, increasing the scale. That we may as okay do by as okay increasing the PRF. And by doing so, it's okay we increase the Nyquist limit. That we can use, yes, okay, get rid of aliasing. But if we increase the scale, yes, okay. This flow reversal here is okay, which was, in this case, is okay, a very low negative. In this case, is okay, was a very low positive. Which we might, okay, as have had even here, that's okay, you can say. This aliasing could still be false. still will be followed by a flow reversal. But as we increase the scale is going to become less sensitive to this low velocity that represents your flow reversal, and pretty much is eliminated out. Did you ladies get that? Likewise, ladies, we can also say that we have two neighboring blood vessels. Let's just do it this way. A and B. And here's that's going to be the same as A and B. Yeah. Now let us just say that as in vessel A is we had let's say it's aliasing. Whereas in B is we just only had as a low Doppler shift. Now in this instance here is if we apply the wall filter, what that wall filter may do, it can only eliminate the lower Doppler shift. But the aliasing is still going to be there. Because wall filter is not able to get rid of aliasing. Why? Aliasing mainly was as a result of high Doppler shift frequencies on our scale, right? Right? The wall filter only has eliminated low velocity Doppler shifts. Whereas in the same example, same blood vessels, maybe it's still says in the top blood vessels we have it says we have releasing, whereas in this lower blood vessel or B blood vessel we still have as a low velocity. But what may happen as as we, for instance, we can say increase the scale. We may actually will be able to get rid of the aliasing. And due to increase in the scale this blood vessel here. So may actually also still have show a negative Doppler shift. Did you girls get that?
Yeah.
Now, ladies, any questions? Now, some of you may ask, where do we find the wall filter function or knob? Right, okay. Because you will see it on both of your Doppler modes. Okay, it's only written on the spectral Doppler, but that's okay. Okay. Wall filter. Well, girls, it is the same knob. We previously said was having your PRF. But if PRF is okay, as inside the bracket, what's going to be outside the bracket is going to be wall filter. And now as you okay, may for instance, okay, turn it's not clockwise, as okay, you increase the wall filter. You may reduce the or decrease the wall filter by turning this knob here anti-clockwise. And the way to switch was, as I said, just slightly push on this button. And as you push, PRF will go outside the bracket, wall filter will go inside the bracket. And then it's going to be PRF that will be active and wall filter that will be inactive. Did you ladies get that?
Yeah.
Good. Any last word of wisdom? Yes, girls. Now, this was your chapter number 20. Now, before I end the session, let's just plan for Monday. Oh, yes, check.
So, on the email, you stated 21, you missed, is it 21, 23, and 24?
You
Because
right?
I thought it was 21, 22,
Yeah, hold on,
skip
hold on, hold on.
23, 24. Because you said, because 23 is about, learning, you said that we did that in patient care with the principles, the major principles of medical
Yeah,
ethics.
yeah.
So we're gonna go 23, I mean 22, not 23.
Yeah, okay, whichever. 22 is, 21 is okay as your artifacts.
Mm-hmm.
22 is okay, quality assurance. So yes, okay, sorry.
I just wanted to make sure.
And that's going to be as okay, a half-hour thing. That means okay, just 2 videos that I will show you. And okay, 1 or 2 topics. Not
For
even
22?
in chapter 22, yes.
Okay.
Okay, so that chapter is going to be done in okay as in the blink of an eye. And then we just left with chapter 24. And you girls will be disappointed because there's really not much to talk about either in that one. Yes. So practically speaking, it's okay. The only real chapter with some meat on it that we have left is
21.
21. Artifacts. Okay, girls. So what are your plans for Monday? Do you girls want to have a SSD or an
That means
What's
study session?
SSD?
huh?
What's
That study
SSD?
session?
Self-study day?
No, I'd rather do
No.
artifacts.
Yeah, or the one that is only half an hour, maybe.
Okay,
that.
and what are you going to do for the remaining? Is okay, 4.5 hours.
Then we could do like a study session. It don't have to be a self-study session.
Okay, but listen, girls. Okay, let's do it this way. You have the weekend
Yeah.
to do what?
Study.
Read, not just read, but eat. Chapter 18, chapter 19, and chapter 20. So what I mean is, okay, we can start on, it's okay, on Friday, on Monday, sorry, with Titanic, editor cut version of Titanic. We see your two movies. Not really, it's like, okay, 10, is okay, videos of, two videos of 10 minutes duration each, approximately. And our main is okay, tell you, okay, on this page, this topic, that's mainly is okay, what you will need to know. That can be asked. And, well, okay, yes. But after that, I will be expecting you girls to be bubbling with questions. Not, if you don't have any questions, I will finish the session and say, well, okay, ladies, I will meet you girls in the school in an hour. And we will check your quiz then.
Eh?
Yeah. Then the choice is yours.
We'll
Okay.
have questions.
Let me know.
We'll have questions. We'll have questions.
Okay, please. Okay. Like, yes. 2 videos of 15 minutes or even 10 minutes. Okay, 20 minutes. 9 to 20. 5 minutes of me telling, okay, page this topic. These are the points. 9:25. So even if you meet up in an hour, 10:25, you can still take your quiz. And that's provided that you don't have any questions, okay? Okay. Now all that says, okay, now we can say, okay, our emphasis, our main focus, that okay, could be on, yes, okay, chapter 19, 18, 19, and 20. But, any questions outside that is more than welcomed as well, okay? Did I make myself clear?
Yes, you did.
Okay, so it's going to be you who will be asking and I be answering. So please have your questions ready by Monday. Okay, girls? Any last word of wisdom? Punchline?
Wisdom.
Good.
Wisdom. That's it.
Okay. Then, okay, girls, have a blessed weekend. I don't know what the weather is going to be like, but anyways, you can't care less. Okay, have fun.
All right, bye.
Okay, bye bye. Yeah,
Thank you.
you're welcome. Yeah.
Hello.